Recording will start then. Okay. So,
Sure.
good evening to each and everyone, and respected speaker of today's session, Mr. Sanjay Namdeo sir. So, it is my proud privilege to introduce Mr. Sanjay sir. Sanjay Namdeo sir is director in Genems Consulting Engineers. This company is basically a research-based end-to-end energy efficiency and sustainability solution. Sir is BTech in Mechanical Engineering and MTech in Energy Management in the area of specialization Energy Efficiency and Management, Water Audits, and Greenhouse Gases. Sir is having 19 years of experience in India and abroad in energy and water audits, energy efficiency design, maintenance, implementation of resource efficiency project, implementation of ISO 5001 energy management system, greenhouse gas accounting, having experience of working with more than 500 industries, including auto industry, cement, sugar, FMCG, food, pharma, textile, distillery, bottling, etc. sectors in India and abroad. Sir have completed imported more than 200 training courses in energy in India and abroad, have successfully implemented large-scale energy efficiency projects from various agencies like Bureau of Energy Standards, WB, UNIDO, GEF, SIDBI, etc. Presently heading the energy efficiency and sustainability services of Genems Consulting Engineers Private Limited. So I welcome you, sir, and I request all the participants kindly make this session very interactive. Energy and energy audit is a very important and hot topic in today's scenario. So over to you, sir. I again welcome you and thank you for accepting our invitation to deliver a talk in this session, sir, in this ATAL FDP program.
Thank you so much, Dr. Abhishek. And
Sir, please switch on your camera for photographs, sir.
Sure,
Yes,
sure.
I request all the participants
All the
kindly
participants.
switch on your camera for just for a while so that we can take one group photograph with Sanjay sir. I request all the participants just for one few seconds only. Mr. Devarajan,
Sir, yes,
kindly
sir.
switch on.
Yes, sir. Sir, you can start presenting
Yeah.
your first slide. You can present your first slide, sir.
Sure, sure.
Yeah.
Yeah, is it okay?
Yeah.
Yes, sir. Yes.
Yeah.
Thank you.
Yes. Yeah. Mm. Thank you, sir.
So can I now switch off my video?
Yeah,
For
yeah,
the
yeah.
better- Yes, thank you. So thank you, Dr. Abhishek, and good evening to all of you. And thank you for giving me this opportunity to discuss about the approach to energy management and climate action. I always enjoy delivering such talks among the educational institutions. I also impart lectures as guest faculty to other institutions like Thapar University and my own university, Devi Hala University, Indore, wherein still I am associated and deliver lecture on energy management. So energy, as you know, it's a very, you can say, hot topic. And now not only energy, the industry is talking about decarbonization and net zero. So from that point of view, and of course, like when we talk about the decarbonization or the GHG emission or the carbon emission, so energy is one of the key source of GHG emission. So all the climate initiative or climate issues are with respect to the emissions, which are ultimately related with the energy. So energy management or energy efficiency plays an important role in the decarbonization or the net zero journey of any industry or for any country, or maybe for the whole world. The topic is now how we decarbonize and how we achieve the net zero target uh, to limit the adverse impact of the climate changes. So I since come from the industry experience. We work with industry. Every year we audit around 40 to 50 industry of different scale and different sizes. So we also learn a lot of many things from the industry. And so industry are like you can say our R&D hub. Therein we learn also, we understand their issues, and we also try to address their issues by like mutual learning, understanding their problems, and also sharing the learning from one organization to another organization. So that gives us like great opportunity to address the issues and challenges of industry. So my lecture is nothing but just like a compilation of how the industry are addressing the energy and the climate issues, and what are like beyond that, what are like you can say the, the key challenges with respect to means you can say the limitations, or maybe the limitations or the gaps in the present way of managing the energy and the climate, and in order to address those gaps, what we should do. So that is what I would like to present in this next 1.5 hour session. So as shared by you, I represent these NM's consulting engineers. It's a basically startup. Around we are a team of 15 plus energy experts, and we work with industry on various aspects of sustainability, which includes energy, water, then GHG, ESG, and also we do a lot of hand holding or capability building in terms of imparting the trainings on various subjects. And with, as I mentioned, during last, let us say, 15 to 19 years, we have worked with so many industries on various aspects of energy and related subjects. So now coming back to like today's topic. So basically, I would like to divide my talk in 4 different segments. The one is understanding the current challenges and opportunity. What is driving industry to work on energy efficiency? What factors are influencing industry to work on energy efficiency? Or for that matter, not only industry, for anybody. What are the factors which are influencing, or what are the factors which are, you can say, forcing them or maybe motivating them to work on energy efficiency and sustainability? That we'll try to understand. And what are the advantages or opportunities for industry if they are working on the energy and the climate? So including their, let us say, the reduction in the cost of manufacturing, maybe their the business sustainability or profitability. So we'll try to understand the opportunity. So beyond the challenges and opportunity, every industry or organization, or let us say the industrial sector, has their own way of managing energy. So we'll try to understand what is the approach industry follow to work on these sustainability aspects, what scope they are covering under the energy and the climate, at what speed they are achieving the performance, and in the present way of managing, what are the gaps which are limiting them to achieve the maximum savings or maximum advantage out of their initiative. So the second segment is understanding how the energy is being managed today. Then we'll try to understand if we have to achieve the best performance or maximum energy efficiency, how it should be done. So then we'll try to understand the difference between the present way of managing energy and what is the best way or approach to manage energy, what scope they should cover under the scope of energy or the climate, and at what speed they should achieve the performance in terms of the you can say the as a time bound you can say target and roadmap to achieve the performance. And the fourth aspect is again many organizations, they start good, they achieve good savings, But with the time, what happens? They are not able to sustain their initiatives. So with the time, maybe because of the change in priority, or maybe some other urgency or priority area, the sustaining of the energy efficiency is a question. And maybe after a few years, we have seen that their energy performance comes back to the previous level, right? So we'll try to understand how to address this issue. So I would like to discuss these four aspects today in terms of the clarity, like what is the challenge, what is the present way of managing or addressing those challenges, what are the gaps and how it should be done, and then how to sustain this initiative in the long run. So challenge, we are all aware in terms of, let us say, the broader perspective, the climate issues, that is like the means environmental impact of the GHG, or the climate or the energy consumption. But beyond that, if we talk about in terms of the demand for the energy. So on the one side, energy is the key, you can say, area which leads to, or which is the source of GHG emission. On the other side, energy is the basic requirement or need for any developmental activity. So on the one side, we have to limit the uh, emissions related to energy. But on the other side, the demand for the energy is day by day going up. And it is expected that in the next 5 or 10 years, or let us say by 2040, it is expected that energy demand would go up by 40%. So on the one side, the energy is leading to the emissions, which is impacting the climate. On the other side, the demand for this utility is increasing day by day. So this creates a basically impossible scenario for secure or low carbon energy supplies to keep pace with the demand. So ultimately, if we add up more sources of energy generation, more power plants, so they will lead to more, like, let us say, generation of emissions. So it's a kind of a dual problem. On the one side, the demand is going up. On the other side, the energy is leading to the climate issues. So if we consider that the next 40 years, the demand is going to increase by around 50%. So that is one challenge for us. The other challenge is we have to limit the CO2 emissions by half in next 10 to 15 years. Even Government of India has also taken target to reduce the CO2 emissions of its GDP by around 35 to 40% in next 5 to 10 years. So one challenge is demand is going up. The other challenge is we have to limit the CO2 emissions by half. So if I multiply these both the parameters, we need to be 3 times more efficient if we have to meet both the goals. It means adding sources of energy which are, let us say, non-GHG emissions or renewable sources. Also, we have to conserve or reduce the energy consumption, and at the same time, we have to also reduce the CO2 or GHG emissions by half. So that is a really next to impossible, you can say, target. And if on the other side, again, if we talk about uh, the overall efficiency or the inefficiencies of the power generation itself. So you might have heard, like, it is always said that 1 unit saved is 2 units generated, right? If you save 1 unit at the user end, it leads to equivalent to generation of 2 units. But if you see the complete cycle of the energy generation, it is not 1:2, it is actually 1:7. So if we reduce the 1 unit of energy at the end user, we can save 7 units of equivalent energy, which is burnt in the power plant to generate uh, the, the electricity or the energy. So it means if without without achieving or without working on the energy efficiency, our climate, you can say, targets would not be met. So in that case, energy efficiency plays an important role in the decarbonization and the you can say the climate action journey. So this 1:7, if we how it has the value has come. So we generally say 1:2. So I'm saying it is 1:7. So if we consider all the inefficiencies right from the let us say the burning of fuel in the boiler, and from there the steam is generated, the steam runs the turbine, and then electricity is generated, electricity is transmitted and distributed through the distribution system. There are also losses when the electricity is coming to the particular at the user end, maybe the industry. So they have their own distribution losses. The equipments which are used in the industry, let's say motor, compressors, fans, and blower, etc., they also have their own inefficiencies. So if I multiply or consider all inefficiencies in the cycle, the ratio comes around 1:7 and not 1:2. And of course, units of electricity generation also leads to one unit of electricity use also leads to 1.6 kg of CO2 emissions. So these are the challenges, and the biggest challenges, like as we are a developing country, so our social and economic growth is dependent on the energy. So in the long run, what is important? The for our social or economic developmental needs, we need to have the secure availability of energy, and that too the availability of this energy from the sources that are affordable to us, accessible, and environmentally friendly as well. So we need energy, but now the time is, or the requirement is, that this energy should be affordable, accessible to all, and should be also environmentally friendly. So in that case, or in that scenario, energy efficiency and its conservation becomes one of the most cost-effective measures to bridge the gap between the demand and supply. So if I just tell you the figure, let us say when we say the cost of energy generation, or let us say the capex required to put up additional power plant, for example, let us say we need 1 megawatt of additional power. So we have the option to go with this additional 1 megawatt of power either from the renewable sources, maybe solar power, or let us say wind, or maybe the hydro. Or if I go with the this additional 1 megawatt from the non-renewable sources like the coal-based or the gas-based power plant, right? So there is always a cost associated with the putting up a new power plant. So and this cost varies maybe in the range of around 4 to 7 crores per megawatt of power generation. So if we have to add additional power plant for our developmental needs, it will incur the capital expenditure, and for 1 megawatt of additional power generation setup, the cost comes around 4 to 7 crores per megawatt, right? On the other side, if I can reduce or I can improve my energy efficiency so that I make this 1 megawatt additional power available by savings from the present consumption. So in that case, when we say like by improving energy efficiency or conserving it, if we save energy, so there would definitely be some cost also involved. For example, if you have to replace your old equipment with the energy efficient equipment, or we have to adopt, let us say, better technology which consumes less energy. So in that case also there would be some cost involved. But here the beauty is, if we have to save 1 megawatt of additional power by improving energy efficiency, the cost required would be around 1 to 1.5 crores. It means as compared to putting up a new power plant, which will cost us around 4 to 7 crore, improving energy efficiency will cost us around 1 to 2 crores only. So in that case, energy efficiency and conservation becomes one of the most cost-effective measures to bridge the gap between the demand and supply. And in addition to this cost benefit, the energy efficiency and its conservation would also help us in mitigating the environmental impacts of this rapid growth, or the environmental impact of the higher energy needs. But if we talk about the energy management or energy efficiency, so in India, like I started my career in this domain in 2000 around 6, and from 2006 and today, there has been a lot of like action on energy management. Our industry has done tremendous work on improving the energy efficiency, and they are at a certain level. And you will be happy to know that in some of these sectors, India is among the best in the world in terms of the specific energy consumption. So one of such sector is cement sector. So globally, India is among the lowest energy consumer in terms of the per ton of cement production, right? So it means we have done good work. We have already achieved a level of savings. So from here onwards, the path to success in the energy management is now getting steeper and steeper, because we have to now go into the micro details. We have to do really more effort, apply more efforts to achieve the energy performance. Right. So in this case, now what is required? We need better information, better technology, innovation, or knowledge to further exploit the potential of the energy conservation. So this is the background. Now, if I again link it, the industry or the energy consumers with what is happening globally. So today it is not the choice of the company whether they improve their energy performance or not. It is basically the, you can say, the basic requirement to sustain their businesses, because climate risk is affecting everybody. So it is now being viewed as a financial risk, and which is a driver for the business insecurity. So it means a company who is not working on these the climate issues or the energy performance, maybe their buyer will stop buying the product from him. So if the company is not demonstrating the improvement in their energy or sustainability performance, it is then a question on their business sustainability. And also, if they're not, let us say, working on reducing these resources or resource consumption, of course, maybe with the time they will not be able to sustain in the market, because their product would not be, let us say, financially viable. So that is the scenario. It is a must requirement for everybody. But what is required? There's a need to accelerate the energy efficiency and environmental sustainability drives by all stakeholders. So there are some reasons why this is required. So let us say, if we talk about from the global or the country perspective, so India has also done its has given its commitment that will reduce our intensity or the emission intensity by around 30 to 35% by 2030. There are now very stringent emission norms, and let us say there are many initiatives. For example, the doubling the rate of energy efficiency, that is the Bureau of Energy Efficiency's call, and also the achieving net zero. So every industry or every you can say the big corporate, they have to declare their the net zero target, because India or every country has also they have to declare their net zero target. So in the net zero scenario, then all the resources would come into you can say the picture in terms of their commitment with the time bound target to achieving the net zero goals. So these are some the drivers, or you can say the forces which are you can say the factors which are forcing the corporates or industry to work on the sustainability or net zero goals. On the other side, if the company has to sustain its business, has to reduce its manufacturing cost, so in that case, they have to reduce their energy consumption, because the energy prices are also going up, right? Last week I was in Assam, so they told me, I was in a plant. So they said earlier last year our power cost was around 7 rupee average. Now we are paying around 9 point something rupee per unit cost. So it is a significant increase in the power cost. So if the company has to reduce their cost of manufacturing, definitely they need to. They don't have any control over the cost of the energy, but definitely they have the control on the how they reduce the energy consumption. So that is again a driver or a force which is acting or which is like compelling or forcing the industry to reduce their energy consumption. And the third is pounding regulations. There are so many regulations which has come up. If you are aware about the BEE's Bureau of Energy Efficiency PAT scheme, so there's again like it's a like obligation for the large corporates to limit their specific energy consumption. You might be knowing that recently there's a there's you can say obligation from the European countries that is called the CBAM, right? So any let us say um, they have under the CBAM, they have taken 5 6 different materials in the product. So whatever, if somebody is exporting to Europe, or those 5 6 materials or products, which includes cement or steel as well, so they have to come, uh, you can say, comply with the European norms in terms of the GHG and the energy consumption or the reduction. So I mean to say, the buyer will only purchase the product if we are complying with their norms. So that is also an obligation. Similarly, there can be so many obligations, maybe the state level or the central level, or maybe the buyer level, OEM level, globally, which are again forcing us to act on the climate sustainability. And the fourth one, again, since we are like the dependent on other countries in order to meet our energy demand, so around 80% of the energy needs we are importing. So it is a question on our energy security, and if we have to really like reduce the dependency on the fuels or the fossil fuels or the energy coming from the other countries, we need to adopt the better performance in terms of the energy. The other two drivers, like innovative business models and the technology innovation. So today, there are so many business models, and there are so many developments happen in the technology space, that these two factors are actually motivating us to adopt energy performance. You might be aware a very simple equipment like the ceiling fan, which we use in our houses. Earlier, the power consumption was around 55 to 58 watt per fan. But now with the BLDC technology, the power consumption of these fans has come down to around 28 watt. And LED, you are already aware. Similarly, in industries also, there are so many technological advancements happen. Like they are really giving us good reduction in the energy consumption with a better return on investment. Means whatever money is spent on replacing those technology, it is paid back within 1 to 3 years time. So that is again something which is like a good news or good factor, which is really motivating us to work on the energy performance. So as I mentioned, like from the energy point of view, Bureau of Energy Efficiency is the nodal agency, which is a part of the Ministry of Power. And the Bureau of Energy Efficiency is driving many programs. So many of the programs are regulatory in nature, and many are the promotional in terms of like motivating industry to work on the energy performance improvement. So some regulatory schemes are, for example, standard and labeling, and then this PAT scheme, demand side management, energy conservation building code, and also the examination for certification for energy auditors and managers. Similarly, there are many promotional programs. And finally, all put together, now the bigger goal for every organization or the country is to how they fix a target for achieving the net zero, and not net zero only energy, net zero water, waste, or finally, again, like the net zero carbon emission. So world is talking about 2050, India is talking about 2070, and many corporates are talking in terms of 2035, 40, or 45. And if I talk about from the industry experience, how it will benefit in terms of the reduction in the energy consumption and the cost. So any industry, if they are working in a continual and sustained manner, they can achieve energy savings as high as around 30% of their present energy consumption. So out of this 5 to 30%, maybe 5 to 10% can be achieved by following the best operational practices. And if we have to really achieve the best performance, so apart from the best practices, we also need to adopt the best systems and the best technology. So this is like the opportunity and challenge in front of us. Now let us understand how industry is managing in terms of improving their energy performance. So we'll try to understand what are the gaps in the present approach, scope, or speed, and what are the limitations of the present approach. So a slightly technical talk here. So when we talk about the energy management practices in industry, so mostly the practice has been to get the energy audit done from the experts, and cost reduction has been mainly by upgrading the technology or the machines which they are using. And many times the technology upgradation or the change of the technology has been based on the technology providers input and by following what others are doing. So let us say I'm working in an industry. So technology provider will come and pitch his product, and based on his recommendation, maybe I will try to take a decision and I will change the technology which I am using. Or maybe my the friend is working in some other industry. So based on maybe some activity or some action he has taken here and he has improved energy performance. So based on his feedback and his, like, let us say, experience, I will also try to improve energy performance of my organization. Or many times this energy management practices are meant only to meet the regulatory requirements or norms. So there's a regulatory requirement that every industry has to go for energy audit at every after 3 years. To, in order to meet the regulatory requirements, many industries just get the audit done after every 3 years. But there is no proper mechanism to implement the findings of the audit. And when I'm totally dependent on the technology providers input, so probably many times what we have seen, that a particular technology has given good reduction in the energy consumption in a particular setup, but in the other industry or other setup, maybe that technology is not compatible and there has been hardly any savings. So there has always been a mixed response, that in one industry the same technology has given benefit, but in the other industry it has not given benefit. The issue is, or the reason is, that particular technology was not compatible to their specific kind of operation or requirement. Right. So in that case, probably solely upgrading the technology without understanding its compatibility with my requirement may not be the right solution. Right. Or maybe just getting the audit done from the regulatory aspects will not give us any, like, significant improvement in our energy consumption. The other limitations has been, like, as of now, industry has been more focusing on utility or major equipment based replacement. So for example, in that case, the major equipments are, like, let us say, pump, compressor, fans and blower, boiler, steam system, HVAC. So replacement of those old equipment has been, like, one of the key area in terms of improving the energy efficiency. But in last, let us say, 20 plus years, hardly there are few industry or very less number of industry those who have considered energy efficiency at the design stage. So for a greenfield project or for a brownfield project, I've hardly seen, like, any industry working on improving their energy performance at the design stage. Mainly energy audit, or let us say energy management, has been a post-mortem kind of activity. Like, there is inefficiency in the current system. So after the diagnosis, those gaps were identified by the auditor, and probably then industry improved those gaps and improved the energy performance. But I have hardly seen any industry, or very less number of industry, those who are integrating or incorporating the energy efficient practices or decision making at the project stage or the design stage. So that is one of the biggest gap. And beyond that, if we talk about what is the speed of improving the performance, means how fast industry has responded or is responding to improve the performance. So still in many of the, let us say, mainly small organizations or medium scale organizations, there is no dedicated team for the energy management. Additional responsibility is mainly given to their existing maintenance or, let us say, the engineering team. There are still challenges in terms of the allocating a budget for the improvement. So if there is no dedicated team working for the energy performance, there is no dedicated, or you can say defined budget for the improvement. So probably what happens, it takes a lot of time or many years for the industry to achieve the energy performance or improve their energy performance. And that too, the other challenges with this ad hoc way of managing energy. For example, if maintenance person is looking after the energy management, probably his core area is maintenance. So his side activity will become energy efficiency, not the main activity. So in that case, if there is no focus, there is no dedicated team. So sustaining of energy efficiency culture again is a big issue. So in a nutshell, if I just summarize, so presently or in for most of the organization, still energy management or the climate action is a ad hoc activity or as and when required activity. It is not a sustained, the you can say the priority area for even today also for most of the organizations, right? And beyond that, even like we have seen like at many places when industry, uh, you can say, they work on energy performance, it is not necessarily like even after their good effort, many times what we have seen, they are not able to improve their energy performance. In and also in many cases what we have seen, after some interventions what they have done based on their own understanding or by maybe input from the external auditors or the technology providers, what we have seen, like in many of the cases energy consumption increased after the intervention rather than the coming down. So there has been many reasons. So uh, I will just share you a very simple case study. Many of you might be aware about the variable frequency drive, which actually modulate the speed of any equipment. And when the speed is changed, the output of that equipment will change. And if the output changes, the power consumption will also change. So one of the common, you can say, issue in industry that most of the equipments are oversized or they are designed for the peak load, but that peak load happens only for 10 to 20% of the time. Right. So in most of the time, what happens that equipment runs in underloading condition. So VFD is a versatile equipment, which is like you can say retrofitted in the common, let us say, the centrifugal or the similar kind of equipment like pump, compressor, fans, and blower, motor, etc. So this is a very simple way of reducing the energy consumption when the equipments are underloaded. So here is a case study of a plant wherein they installed this variable speed or variable frequency drive in their common these equipments. So these included some air handling units, some pumps, some circulation pumps, chilled water pump, etc. And when during the audit, when we actually measured the performance, so we were told during the audit that recently they have gone for the VFD based on the technology provider's suggestion, and technology provider has given them a guarantee of around 20% savings. So when we actually measure the performance during the audit with VFD in line, so we measured the power when the VFD was in line, and we also measured the power by bypassing the VFD, or let us say after the VFD and before the VFD. So what we saw, there's a difference in the power consumption, and with the VFD, the power consumption has slightly increased rather than coming down. So here you can see with VFD, the power has slightly gone up. And total, if I see the difference in all this equipment, with VFD, power is coming around 175.6 kilowatt. And without VFD, it is 166.9 kilowatt. So industry's perception is what? That they have reduced 20%. But what is the actual situation? The power consumption has increased by this factor. So around 8.7 kilowatt power has increased. So whereas VFD is a versatile equipment, it definitely gives savings, but in this case, it is not giving saving. So there are some technical reasons. For example, the VFD is meant for variable load. So when we have to put VFD, we have to reduce its frequency, or we have to reduce its output. If VFD is running at full speed or full output, it will not save any power, but VFD will have its own let inefficiencies, and with that inefficiency, the power consumption will slightly go up. Right. So now you can imagine the investment made for all these VFD. So VFD investment would be around, in this case, around it would be around 10 to 15 lakhs. And with the 10 to 15 lakhs of investment, the power consumption has gone up by 8.7 kilowatt. And if you calculate the monetary value of this 8.7 kilowatt by assuming 320 days per year of operation, 24 hours per day, and power cost of around 7 rupee, so it would be significant, around 7 to 10 lakhs rupee of the loss. So it's a double, you can say, loss for the industry. One is the capex they spent on this project, and the recurring power which has increased, which has gone up. So this is happening in many of the cases. So the reason is like either the technology was not properly understood, or maybe it was not deployed properly, or maybe it was not compatible with their requirement, or maybe it was not implemented properly, right? So still these kind of situations are happening. It means there is still a lot of potential that if these technical aspects are properly addressed before the implementation, industry can definitely improve the energy consumption or energy reduction significantly. Here is another case study of a plant. So earlier system was, they had small sizes of pneumatic, that is the compressor, air compressors. So they had around 4 numbers of 40 CFM compressor, 2 number of 20 CFM, similarly 2 numbers of 25 CFM. So these compressors were running in, like, let us say, attached with the particular machine, and were running in on-off mode. These were the reciprocating compressors. So somebody recommended them that instead of all these smaller compressors, you should go for a bigger size centralized compressor. So the industry changed all this, they scrapped their old compressors and replaced with a new compressor of 230 CFM, 37 kilowatt. But when we actually measured the power consumption after the implementation, although this was the best technology, a new screw compressor as compared to reciprocating is definitely a better technology. But when we actually measured the power consumption, it was consuming around 220 kilowatt units or kilowatt hours per day, more power as compared to the older system. Nothing wrong with the technology, but there is something wrong which led to this increased power consumption, and that was the you can say incorrect size of the new compressor. So by just adding the capacities of old compressors, they added up some margin and bought up a new compressor of higher capacity of 230 CFM. So when higher capacity compressor will run for a lower you can say load or a lower requirement, it will run in the loading and unloading mode. So during unloading, it does not generate any compressed air, but it consumes the unloading power. And because of the unloading power, so it means this bigger size compressor was not compatible with their current requirement or the current flow. So nothing wrong with the technology, but there is a wrong selection in terms of the capacity of the new compressor. So that led to the higher energy consumption. Right. So what is the conclusion? If the proper diagnosis is done and the industry is implementing the projects with a, you can say, time bound you can say target or the solid implementation plan, analysis is done properly, then definitely industry will achieve substantial savings. But on the other side, if the technical analysis or the financial analysis or both is not done correctly, so it may lead to lower than the expected savings, occasionally even higher energy use. So it is a waste of your investment and the bad name for the energy conservation. So these are some very practical cases which we have seen in industry, that after so much of effort and the investment made by the industry, they have not been able to achieve the better performance, right? So it means there are gaps in terms of how they are prioritizing, how they are doing the technical analysis, and how they are prioritizing their implementation, right? So in that case, now let us understand how it should be done in order to overcome, or you can say address these gaps or challenges. So when we talk about, you can say, the holistic approach of energy management, so mainly like this, the conventional approach has been to identify the project and just implement it, right? But if I, on the other hand, if I say what should be the holistic approach, so in that case, apart from identifying and classifying the energy saving projects, what industry need to do, they should focus on these five broad aspects. Like, not only just replacing the technology, what industry should do, they should first of all do the assessment of their proper capacity utilization. Like, what is the installed or design capacity, how much is the utilization, what is the size of the equipment, what is how much, what is our requirement. For example, starting with the production capacity of the plant, what is the rated output of my plant, how much is my present production. Similarly, what is the rated capacity of my chiller, what is the actual utilization. And similarly, this practice or this study can be, you can say, replicated to entire plant and the entire equipment. So first thing is they should know what is their capacity utilization factor. Then the second aspect is they should focus on the fine tuning various parameters. For example, time, temperature, pressure, batch time, batch operation, your let us say voltage losses, maybe power factor, etc. So there are so many parameters. If we fine tune them, it can result in significant savings without much, or without any investment, or without much investment. So that should be the focus. Third, as very simple example of fine tuning is, you set your temperature, AC temperature, either 20 degree, 22 or 25 degree. In all three cases, the power consumption would be different, right? Next comes then the technology upgradation. Once we have done the all the fine tuning or the capacity utilization study, then we should identify the technology upgradation needs or the technology gap, and then probably we should, you can say, then only think of adopting the technology. The next aspect is, like every industry, they grow with time, they add up new plants or they expand their existing. So in that case, they should make a mechanism of the process that energy efficiency should be addressed at the design stage. And for the existing plant, they should have a proper policy that whatever equipment or the system they will purchase, it should be energy efficient by design. So that is one difference in the approach which we can follow. Similarly, not only we should look for the projects which based on the let us say payback period, that I will implement projects only by adopting the technology, and that technology should have a less than 2 years payback period. Beyond that, what industry should do, like apart from the technology upgradation, they should look for no investment savings, medium investment projects, and then long term projects. So not only like the capital intensive project, they should also look for small savings which does not require any investment. And then the focus should be on, you can say, the sustaining the energy management practices, not only just implementing. So year on year, they should be able to, you can say, make a system or make a process so that their energy is addressed as a priority area by all level of people in the organization, whether it is an operator or whether it is the boardroom, the top management. It should be the concern area for everyone. So it is not only that it's a shop floor activity, it should start from the boardroom, or the priority should be fixed at the boardroom. And third is, it is not only few equipment or the system which are responsible for energy consumption. So in that case, whatever is consuming energy, all electrical and all thermal energy consumers, whether it's small, big, or large, not only the equipment, we should also focus on the process and system, or not only the process and system. If I have to achieve the best performance, my entire plant should be safe and reliable as well. So let us say issues like let us say from the electrical point of view, if I talk about, there are issues of harmonics or earthing, or let us say reliability of the equipment. Those also should be addressed as part of the integrated energy management system. And then probably what industry should do, they should have a proper energy mapping of the entire, you can say the plant, like how much energy is consumed in which particular section, what is its ratio, and what is, let us say, its significance. And then comes the where we stand in terms of comparing like the ourselves with the internal or external benchmark energy consumption, that as compared to, let us say, the competitor, or as compared to the global benchmark, or as compared to, maybe there are 5 different units within the same corporate. So as compared to those 5 units, where we stand. So that will give us a direction, a comparison, and also a direction that means where we stand, and then probably achieving the best possible performance. Yeah, Dr. Abhishek, actually, what is the time allocated to me? At what time I have to close the session? It is 8:40 now.
Yes, sir. Sir, we can continue up to 9 p.m., sir.
Okay. So practically I have around 20 minutes time, right?
Okay, sir. Yes, sir.
Okay. I'll try to skip some slides. And again, when we talk about, let us say, again, the scope of energy management. So let us say, if I talk about a very simple equipment, air compressor. So what is the current scope industry consider? Only replacing this compressor with a new compressor. That is the scope for many of the organizations. But if I mention, or if I talk about what all influence the energy performance of the compressor. So performance of the compressed air system consists of many aspects, which may include even location of the air compressor, maybe the line sizes, maybe the receiver capacity and the receiver location. All these factors influence the performance of the compressed air system. So it means just by replacing the old equipment with the new equipment, or the inefficient equipment with the efficient equipment, will not serve the purpose. We need to go into the micro details of all these factors by proper study, and then identify gaps, whether my line sizes are proper or not, my receiver location is proper or not, whether my location of the receiver is put at appropriate places or not, what is my leakage level, what is the loading and unloading pattern of my compressor, what is the consumption pattern of my compressor. All these factors influence the energy performance. So just by replacing old with the new one will not serve the purpose, right? So quickly, I will take you through the 4 major factors which impact energy efficiency in let us say in an organization, or it is applicable to most of the industry or the institutions. The factor 1 is the energy and the life cycle cost. So this is a performance parameter of a chiller, which was audited some time back. So here you can see this chiller is how much? This is of around 615 TR it is generating. This is the actual power consumption. And here you can see the specific power consumption, that is kilowatt per TR, how much this chiller is consuming, right? Similarly, this is again the performance of a different chiller, that is J5 chiller of industry, right? So it means any equipment, it has some energy consumption, right? There is some specific output of this equipment. So there is a total how much power it is consuming, right? Then what we have, the running hours, for how many hours this equipment is running in a year or in a day. And there's a power cost, and based on the power cost and based on the running hours and based on the kilowatt, there's a cost of energy which this equipment consumes every year, right? So it means what are the costs associated with any of the equipment? The one is the energy cost. The second one is the initial cost when this compressor was bought in the company or when it was purchased. And the third broad cost would be the maintenance cost, right? So in a life cycle cost scenario, the life cycle cost would consist the energy cost plus the initial cost plus the maintenance cost, right? So if I just calculate the life cycle cost of these two chillers, right? So energy cost is coming around 254 lakhs per year. And if I consider life of this equipment around 10 years, so in 10 years, this equipment will consume power worth 25.4 CR, right? Or 254 million rupees. Similarly, if I again just estimate the initial cost of this equipment, it would be around 400 lakhs or 4 crore, or let us say 40 million. Life I have taken 10 years. In 10 years of life, it will require some maintenance, maybe scheduled, unscheduled. So there would be some maintenance cost as well. So if I plot a graph between the ratio of what is the percentage of initial cost, maintenance cost, and the energy cost in its life cycle cost. So life cycle cost is nothing but the sum of initial cost, maintenance cost, and the energy cost. So here you can see the energy cost consists of around more than 95% of its total cost in the in the lifetime of that equipment. And initial cost is hardly 2 to 5%. In this case, it is hardly 2%. Maintenance cost also in the range of, let us say, 1 to 5%. But broadly, the energy cost would be around 90 to 95%. Right. So it means life cycle cost, the energy component in the life cycle cost is significant. But on the contrary, what is happening in industry, that whenever a new equipment is purchased, the decision is mostly taken based on the initial cost. And still that L1 approach is prevalent in India, that most of the purchase or the purchase decisions are based on the initial cost rather than the life cycle cost. So let us say, if we consider the equipment selection based on the life cycle cost, so energy efficiency would automatically come into picture or in the discussion or in the consideration to select a appropriate technology or appropriate efficiency of the equipment. So the first gap or the first factor which is influencing the energy performance, that is when we are purchasing or when we are like putting up a new plant or when we are replacing old with the new one, we are not considering or we are not looking into the life cycle cost of that equipment, but our decision is just based on mostly in case of in the based on the initial cost. So this is a big factor which is influencing the energy consumption in long run. So there is another example. Now there is another perception. There is another perception that energy efficiency at design stage would cost us more. So very simple, if I say, let us say there's a efficiency 1 equipment and efficiency class 2 equipment. So our general perception is what? Efficiency class 2 equipment would be costly, right? But it is not true if we really select the proper size of the equipment. So here is another example. In industry, there was very large size of cooling tower pumps, right? Existing pump was of 200 kilowatt with some parameters of head flow and the power. And when we did the audit of this plant, what we found that this pump is over designed, and the correct size of the pump would have been only 120 kilowatt of motor, and based on that, the rating of the pump that is head and flow would have been different. So what is the issue in this plant? Let us see. These are the 3 pumps. installed in this plant, and you can see the rated parameter 1250 meter cube per hour, 42.5 meter head, and this rated power of the motor. Actual performance parameter here you can see. These three pumps are means generating, or let us say delivering 1000 meter cube of flow. Operating pressure is 3.1 kg or 31 meter, and this pump is consuming 179 kilowatt. So these are the rated and the measured parameter. Now, during the audit, what we saw, that this pump is being controlled by the throttling valve, and this throttling is done at the suction of the pipe. And the outlet is again like fed through a common distribution pipe to various users, right? And here also, these are the control valves, right? So it means there is something when we are controlling the flow by operating the valve, and this suction valve was closed around 80%. So very simple indication, if the pump is being operated by valve control, it means the pump is not correctly designed. So here you can see the design head is 4.2 kg or 42 meter, whereas the operating head is 3.1 kg only. So those who are from the, let us say, the mechanical engineering background, they can understand that this pump is highly over-designed by head. So if the pump is highly over-designed by head, so a higher head pump operating at lower head will deliver more flow and will consume more power. So in order to restrict that flow and the power, they throttle the valve. It means what is wrong? The pump is not correctly designed. So now the question is, what should be the correct design, or what should have been the correct design of this pump? So that we calculated. The correct design of this pump should be 1200 meter cube of flow, 27 meter of head, and only 120 kilowatt of motor capacity. So now you can well imagine the cost of a 1200 meter cube pump, 27 meter, and only 120 kilowatt of motor, as compared to what is the present size. Present size is 1250 meter cube, 42 meter, and 200 kilowatt of motor. So if the company would have gone for the correct size of the pump, the investment would have been less as compared to the present investment for a 200 kilowatt pump, right? So one gap is what? This higher capacity pump has cost us more, around 25% higher cost. Also, what is the gap? See, present power consumption is how much? 179 kilowatt. Had this been of the correct size, the power consumption would have been how much? Only 120 kilowatt. So 59 kilowatt of power difference per pump. And this 59 kilowatt of power difference is equal to around 62 lakhs per year. At a power cost of only 5.3 rupee, this plant is running for 350 days per year and 24 hours per day. So if this 120 kilowatt pump and 1200 meter cube 27 meter pump, even if we take off the best efficiency with a higher cost, still its cost would be less than the incorrect size pump of 200 kilowatt and the 1250 meter and 42 meter the head. So the message is, if we can design or we can size of our equipments correctly, the initial investment would be less. So energy efficiency at design stage may definitely reduce the initial investment as well, right? So that is the so it means when we are able to size the equipment correctly, right, definitely we can save on the initial investment. And even if you go for the higher efficiency equipment, our life cycle cost would be definitely much lower than the life cycle cost of a incorrect, inappropriate, inefficient equipment, right? Okay. Now the second factor is equipment efficiency versus system efficiency, right? So what we discussed, like mostly the approach of improving the energy performance has been what? Replacing the equipment, old equipment with the new equipment. But let us understand what is this concept of system efficiency. So this is just like a block diagram of a, HVAC system. So you might be aware, in a HVAC system, what are the various equipment? So there is a chiller, right? So this chiller, if it is, so there would be a chilled water circulation pump. If this chiller is water cooled, so there would be a condenser pump. This condenser pump would dissipate the heat where? At the cooling tower. So there would be a cooling tower, and the chilled water would be supplied across what? Air handling AHUs, or maybe some process area. So this HVAC system has how many? 5-6 different equipment, right? 5-6 different equipments. So for me, if I have to make the HVAC system as such efficient, so my focus is not only like my chiller should be efficient, my focus should be what? My entire system should be efficient. So what is the second approach? Rather than focusing on the equipment efficiency, we should focus on the system efficiency. Now, how would be the difference? Here you can see, this is again the actual parameter. The chiller is consuming how much? 82 kilowatt. It is delivering 112 TR, and there's some actual specific energy consumption, and there's a rated or design specific energy consumption. So design is 0.65 and operating is how much? 0.73. So this is for the chiller, right? Whereas if I see the system efficiency of the entire HVAC system, so what is the rated? Rated is 1.02 kilowatt per TR, whereas my design is 0.75 kilowatt per TR, whereas operating is how much? 1.02 kilowatt per TR. So when I'm just looking this chiller equipment, so I can still say that the actual is close to design, right? But when I compare the system efficiency, then I will come to know the actual picture that my system efficiency is much lower than the design system efficiency. So it means we should focus on considering the efficiency of the entire system, not only one equipment. So what is the rule of the system efficiency? Here you can see, let us say in a system, let us say if you consider my system is what? My system is a fan which is coupled with a motor, and motor has some, let us say, starter or drive. So what is my system? My system is all these four equipment. So let us say the efficiency of the drive is 98%, efficiency of the motor is 96, efficiency of the coupling is 0.95, and efficiency of the blower is 0.7. So these are the equipment efficiency, whereas system efficiency is what? The multiplication of efficiency of each equipment, right? So my system efficiency is 0.62. So system efficiency consideration will give us the correct picture whether my entire system is efficient or not, rather than going only for the let us say equipment base. Now consider a case that my blower is only 30% efficient, keeping all other equipment same, right? Keeping all other equipment same. So now what would be the system efficiency? Any idea? Would it be less than 30% or more than 30%? So there is another rule of system efficiency. System efficiency would always be less than the efficiency of least efficient equipment. So in the present case, which is the least efficient equipment? This blower, 0.7. So what is my system efficiency? Less than 0.7, that is 0.62 or 62%. If this blower is of 30% efficiency, so in that case, my system efficiency would be less than 30%. It means even if all other equipments of higher efficiency and only one equipment is of least efficiency, the efficiency of the system would be governed by the efficiency of the least efficient equipment. So given a choice, I would first try to replace this least efficient equipment with the higher efficient equipment rather than changing or disturbing any other equipment. So for industry also, it is very important to first of all study their entire system and identify equipments or the processes which are least efficient. So that is the second factor, right? I'm skipping some slides because of the time limitation. Okay, now there is another aspect. Suppose I have all the equipments of best efficiency. Does it guarantee that my system would be efficient? No. If the system, that equipment is of not correct size, we have seen in the pump case study, even that 200 kilowatt motor and 1250 and 42 meter head pump would have been of best efficiency, but when it is not matching with my requirement, my system efficiency would be less than the design efficiency. So same is true for any other equipment. If that equipment is not correctly designed, matching with my requirement, when it will come into the operation, that equipment will not operate efficiently. So that is the second factor. Now, again, I wanted to discuss something about how to design a system. So there's a concept that is called the onion diagram method. So based on the onion diagram method, we can design the system efficiently. But as of now, please excuse me. I would like to skip this discussion because it's a very long discussion. There's a time limitation. So we'll just move to the point number or the factor number 3. And maybe sometime in future we'll discuss about this onion diagram method. So the third factor is what? Third factor is, I'm skipping the onion diagram discussion. And third factor is the proper monitoring and targeting system in place. So it is said that if we have to manage something, the first step should be what? To measure it. So in any industry or setup, there has to be a proper energy monitoring and targeting system in place. Then only we can account for like what is being consumed where, what is the intensity of that energy consumption, how much deviation is there as compared to the benchmark, and then only we can fix target for the reduction and then monitor that you can say the reduction, and then probably fix a timeline to achieve the best energy performance. So this monitoring will help us to account for the energy use in the entire system. It will help us to eliminate some wastage in the energy use by monitoring. When we start monitoring, of course, then we'll have also the mechanism to control it. We'll also be able to understand the why there's that deviation is happening, why the energy consumption is not consistent or it is increasing. So it will lead to some savings just by monitoring. And once we monitor, then only we can come to know how much is the present consumption, and based on that only, then we can set target for the future. So third aspect is monitoring. Now the fourth aspect which I mentioned, there is always the question of or the issue of sustaining the energy efficiency initiative. So what is the issue? That let us say at this point of time of higher energy consumption, plant team decided to take some action, or industry decided to take some action because of the increased energy consumption. So from the baseline, let us say their consumption increased by around 5%. So here there would be some, you can say, spark or some you can say concern about the energy. Industry will start working on the improving energy performance, and after a few months or few years, they will be able to achieve some energy reduction. But again, if there is no sustained practice in place, what will happen? After a few months or few years, again their energy consumption will go up. And again they will do some action, and again the situation will happen, their consumption will come down, and after a few years, again it will go up. So this is called a kind of ad hoc way of managing energy, and this is a sinusoidal way of like achieving the energy performance. But what is actually desired, that with the time, my consumption or specific energy consumption with the time should be continuously be reducing, or with the time I should always be able to reduce the energy consumption year on year. So to achieve this kind of performance improvement, what is the systematic way? There has to be a management commitment. There has to be a, let us say, best process systems and technology in place, basically best system and mechanism in place, then everybody should feel the need. As I mentioned, it is it starts with the top management. Uh, it will also involve, like, let us say, best housekeeping practices in place. Ultimately, there should be focus on building a culture of energy management in the organization. And when it is in place, then probably we should move into the technology upgradation. So that is what is desired in any of the organization. So structured way of managing energy is something like this. And to achieve this, what is required? See, technology is almost same, right? Let us say same pump of higher efficiency can give us better efficiency in one industry, and the other industry it may not give the best efficiency. So what is required? This technology and this people and the process has to be driven by some system, some culture in place, some system in place, and this should be led by the top management, the leadership. So if you have to really achieve the best performance, there has to be a proper, you can say, a system which help or which facilitate the people and the process to use the technology appropriately. So in that case, let us say energy management system, or the, let us say, any such system. For example, in case of energy, it is called the ISO 50001 energy management system. Many industry are adopting these systems, which is able to address their all aspects of energy, whether it is the design and procurement, whether it is review of the energy performance, energy performance indicator, baselining, etc. And it is also helping us to involve the leadership as well in the energy efficiency program. It is also helping industry in terms of reviewing their internal system, involving management for the review, and of course, making a continual improvement plan in the organization. So that is the fourth aspect, which is important, that we should have a proper system in place so that energy can be addressed. And then if you see, as I mentioned, the climate issue, or let us say the carbon emission, is basically because of the uh, energy consumption. So if we are able to address energy properly, probably the climate issues or the climate action would automatically would be streamlined. So if we have to, as a climate action initiative, if we have to work on reducing the GHG emission, so energy is one of the major emitter of GHG. So if energy is addressed properly, probably we'll be able to address this emission or the net zero target properly. So that is about the climate. Now I think the time is, I have just exceeded the time. So what is required? So with the time, the industry need to develop the roadmap, like from here to net zero scenario, what all action and activities they need to streamline. And with the time, not only their own action they need to review or take their own climate action, they also need to involve their entire supply chain. So that is something which any industry should work in terms of a proper roadmap, which starts with the reduction in the energy, and it like ends with the achieving their net zero target or net zero roadmap. So that is what like industry should do. And then each activity will have again the detailing in terms of what all activities they need to do or they need to integrate in their the climate action. So this is like from my side. So I think time is also, I've covered the time. So I would like to then close my presentation here. Thank you so much. Now, if there are any questions, we can discuss.
Thank you, sir. Thank you for giving a real-time things which is happening in the industry regarding energy and audit energy management. From last 3 days, we have been hearing about the energy, renewable energy, and today we have understood about its how we can enhance the efficiency and audit. So really very wonderful presentation. Now I request all the participants that if they want to ask any questions, kindly raise your hand one by one so that you can interact with our esteemed speaker. Ruchika Thakur. Ruchika Thakur. Ruchika Thakur. Ruchika,
Yes, sir.
do you want to ask some question?
No, sir.
Actually, you raise your hand, so
No, sir. No, sir.
any question from participant side?
Yeah. So I think I already exceeded the time limit. So no issues. This presentation I will be sharing with all of you. And
Yes, sir. Yes, sir.
if there is any question, you can connect with me offline, or you can put up a mail.
Raghvin
Dr.
Tiwari.
Abhishek, what I feel ki just after going through the presentation of the learned speaker once again,
Yes,
we
sir.
can ask our faculty members as well as students also to go through the same, and if required, will ensure your help to connect us with the learned speaker.
Sure, sir. Sure, sir.
Right.
Yes, sir. Yes, sir. Sure, sir. Raghavendra Tiwari ji. Okay. So again, thank you very much, sir, for accepting our invitation, and in such a busy schedule, you have taken time and deliver a talk in energy and material. Both are very essential things, sir, in current time. So really, it was very wonderful talk, sir, and thank you very much, sir.
Thank you so much. Thank you for
Thanks
giving
a
me
lot.
this
Thanks a lot.
opportunity to
It was
interact
really
with all of
nice
you.
to
Yes, sir.
listen to
Thank you,
this.
sir. Thank you so much. Thank you for your feedback.
Yes.
Thank you.
Dr. Murli, can you stop
Yes,
the
sir.
recording?
Yes, sir.
Can you stop the recording?
Yeah. Yes, sir. I'm going to stop.
Sanjay sir, good night.
Thank you. Good night. Thank you, everyone. With your
Good night.
permission,